Okay, so continuing on, the next thing we need to be able to do is to verify an inverse function. So if we take an input from the domain of f and we do the function f to it, we get something in the range identified as f of x. Then if we apply the f inverse function to that, we should get back to the x that we started with. It also will work if we take an input from the domain of f inverse and do the f inverse function and get a result, and then do f to that, you should get back to x again. So f inverse of f of x equals x because it's the undoing and the doing. This x, notice, is in the domain of f, and this becomes very important in trigonometry especially. Then it's also true that f of f inverse of x is x, but this x is in the domain of f inverse. So the symbol that's used in both cases that's the x, which is just a symbol, has a very different meaning depending on the order of application. So if you do f of x first, means x is in the domain of f. If you do f inverse first, it means x is in the domain of f inverse, which is the range of f. Okay, so the instructions in this section are going to say verify that the function f and g are inverses of each other by showing that f of g of x, so this is section 6.1, the composing. Make sure that f of g of x equals x and g of f of x equals x. So I'm going to do the first one here on the movie and we'll do the next one in class. So I'm doing f of g of x. Okay, so that says I take the g of x function and I put it in the f function where I see the x. Okay, then I'm going to distribute that 4, and I'm going to get x plus 8 minus 8, which equals x. Check! I've showed that f of g of x equals x. Now I need to show that g of f of x equals x. So I'm going to erase what I did here and take the f function and put it in the g function. So it's going to look like 4x minus 8 over the 4 plus 2. So that's 4x over 4 minus 8 over 4 plus 2. X minus 2 plus 2 equals x. Check. So I showed now that g of f of x equals x. So I have verified that these two functions are inverses of each other. And in this case, it says give any values of x that need to be excluded. And that's much more of an issue in this number 44, so we'll talk about that in class. You can see that number 37, those are both polynomials, and so there are no restrictions on the domains. Okay, the third objective is when a function is presented as a graph. This is the easiest one for finding the inverse function because every ordered pair AB that's on the graph of f will become the point BA when it's on the graph of the inverse function. So basically, the points reflect about the line y equals x, the diagonal line in quadrants 1 and 3. So every point A, B that was on the original graph of function f becomes the mirror image over here, BA. They switch places. Okay, so if you're given a graph of a one-to-one function, we can draw the graph of its inverse. The point 1, 2 is on the graph, so that means the point 2, 1 must be on the graph. The point 0, 1 is on the graph, so the point 1, 0 is on the graph. The point negative 1, 0 is on the graph, so the point 0, negative 1 is on the graph. And then the point negative 2 is on both graphs. So here's the graph of f inverse if this is the graph of f. So the graph of F inverse can be drawn by reflecting the graph of F about the line, the diagonal line, y equals x. Okay, then objective 4 is if the equation is given as, for the function as an equation. So we've talked about maps, ordered pairs, graphs, and now equations. So the equations are usually the trickiest. So I want to do this one together in class, and then you'll notice that the last page of the notes has a little summary of this section.